Assalamualaikum warahmatullahi wabarakatuh and good day everyone. So today we continue again our teaching and learning for soil mechanics. Now we in chapter water in soil, and I will share with you today on total stress, effective stress and pore water pressure. Next. Okay, just want to recap some of the first part of this chapter. Do you still remember, or do you already understand why do we need to know on the water flow and the quantity of the water in a soil region? Do you know? And thus you know that water can affect the soil condition, and thus water can permeate in geotechnical structures such as dams, retaining wall, and etc. Okay, how about the ability of water to seep in unsaturated soil? You already learned about this one. And the rate of water in the soil could represent by a symbol of what? Okay, so if you still doesn't recap, so it's okay. During this slide presentation, I will share with you some of the answers, inshallah. Okay, for the total stress, pore pressure, and effective stress. Okay, before I go further, just want to share with you. This is a figure of a soil profile with a few layers of soil, namely from A, C1, 2C2, 3C3, 4C4, 5AB, and 6BBG. So why it is addressed like this? So maybe it's due to the horizon of the soil. As you remember, A, O, B, and so on that we have learned from a previous class. So basically, each of layer like this one compared to this one, we can see that the colors and also the soil formation here is different from each layer to one layer, and this is very dark brown color. So maybe this is what type of soil, and this is become slightly lighter and deep dark again, and lastly they have a final soil layer. So these differences of the soil layer represent different types of soil. It might be sand, it might be clay, silty sand, silty clay, and so on. I believe we already learned all this type of soil layer and its characteristic in the soil classification chapter. Okay, what I want to address in this topic is every physical interaction between the soil and water are studied using effective stress concept. So what actually effective stress? Okay, an effective stress in a soil actually cannot be directly measured in field, but it can be obtained from relationship with the total vertical stress and also pore water pressure in soil. It can be obtained from total vertical stress and pore water pressure. So if I could sketch a little bit, okay. So we know that in soil we have a soil particle. If you still remember three-phase diagram in the chapter 1. So we have a soil particle. Sometimes we have a gap between the soil particle. So if we could draw a shape for this soil, so soil particle between two soil particle can be addressed, can have a stress between them. A contact or stress between them is called effective stress. So this effective stress could not directly measured because we don't have any straight or direct instrument to measure the effective stress, but it can be obtained if we have a let's say we know that a certain region in soil have a water. Let's say this is water, moisture content, and we know also mass of the soil. Yes, but let's say we have a usually for water pressure we have tools to measure the water, inclinometer or piezometer. So from water measurement and also the total stress measurement, we can minus the total stress. Let's say this is a total stress, stress sub T minus the pore water pressure, a pressure generated from the water. So we can obtain the effective stress, a stress with a comma or a dash, stress effective. So it is important as the combined effect of total stress and pore water pressure will controls the soil behavior, such as shear strength, compression, and distortion. So that's why effective stress concept is very important to be learned, because we want to relate to the next chapter of soil compression, soil mechanic, which is a shear strength, also compression in geotechnic 1, and distortion of the soil body in geotechnics. Okay, so what is total stress? So total stress is a vertical stress acting at a point below the ground surface, basically due to the weight of everything lying above the soil, i.e. the soil, water, and also the surface loading. So total stress can be obtained using this equation: the height of the soil layer times the unit weight. The height of the soil layer times the unit weight. And the unit weight is varies. Let's say we have a dry soil. So usually the dry soil have a average of 17 kilonewton per meter cube. 17 kilonewton per meter cube. It can be ranged from 14 to 20 kilonewton per meter cube. Meanwhile, for saturated soil, it carries much higher gamma saturated, unit weight of saturated, from 18 to 23 of kilonewton per meter cube, with the average of 20 kilonewton per meter cube. Okay. And water itself, it is addressed as 9.81 kilonewton per meter cube, or sometimes for easiness we just we take it is equal to 10 kilonewton per meter cube. Okay, for the total stress, so when an internal stress, external stress is applied to a soil mass, so it especially when the soil mass is saturated, so the immediate effects is an increase in pore water pressure for a saturated soil. So if an external stress is applied, so it will increase the pore water pressure. So this provide a tendency for pore water pressure to flow away through adjoint voids. Then it will result the pore decreases and applied stress is transferred to the granular fabric of the soil. At a given time after application, therefore the applied total stress will be balanced by two internal stress components, which is the pore water pressure and effective stress. Pore water pressure and effective stress. Okay, so what is pore pressure? Okay, the pressure that stay in the pores of a soil is called pore water. The pressure between within this pore water is called pore water pressure. Means pore water that have pressure that have pressure, so it is called as pore water pressure, or can be represented by the symbol of U. Okay, the magnitude of pore pressure depends on the depth below the water table and the condition of the seepage flow. For pore fluid is able to transmit normal stress but not a shear stress, therefore ineffective in providing shear resistance. So if we have a water, so sometimes the soil became more weak, not a strong soil. So for this reason, pore pressure is sometimes referred to as a natural pressure. Okay, how to calculate the pore pressure? So pore pressure can be calculated as gamma water times height of the water. Okay, while pore pressure for capillary zone is negative pore water pressure, so denote as a U sub R rise minus equal to negative saturation SR times gamma water times the height of capillary divided by 100. So if the saturation already in decimal, so no need to divide by 100. So later I will recap what is capillary zone. Okay, as you already learned in introduction last time, so natural static water level in the ground is called as a water table. So if you have a surface, so this is ground. Okay, so usually the water level is follow the shape of the ground surface, and it is represented by a line or a dotted line with a upside down triangle with at least one or two lines to denote this is a GWT, the ground water level, or the groundwater table, GWT. Okay, under the condition of no seepage flow, means water is flow, not seeping into others surface or others layer of soil. The water table will be horizontal as in the surface of a lake. So like follows the shape of the ground. And the magnitude of the pore pressure at the water table is 0. So usually U at this line is equal to 0. Pore water pressure is 0. They have a pore water, but they doesn't have any pressure at the beginning. Okay, below the table, okay, when it goes below, so with the increases of the height, so we have some pressure. Okay, we have some pressure. So how to calculate the pore pressure is the gamma weight, the 9.81 times the height of water. Okay, how about effective stress? So effective stress is the stress that transmit through the soil particles or soil fabric via the intergranular contact. So if you still remember that I'm sketching earlier, so if we have two soil particles, so if they are touching each other, so they have a effective stress. So effective stress can be obtained as the total stress minus the pore water pressure. So denote that the prime or dash mark is indicate the effective stress. Okay, I think later this is similar as before. Okay. Okay, I stop here, so continue in next video.